Hi, so in this video I will show you how we can apply L'Hopital's rule to evaluate this limit you're seeing on the screen right now. So we are given the limit of x plus pi over 2 multiplied by secant x as x approaches negative pi over 2. So if you see over here, we have this function, and if we try to perform a direct substitution, we get negative pi over 2 plus pi over 2 multiplied by secant pi over 2. So this gives us 0. Then 1 over cosine of negative pi over 2 gives us over 0. So this expression gives us infinity. So we have 0 multiplied by infinity. So this is one of the 7 indeterminate forms that exist when evaluating limits. So the 7 indeterminate forms are as so: 0 over 0, infinity over infinity, infinity minus infinity, 0 multiplied by infinity, 0 to the power of 0, then we have 1 to the power of infinity. So 1, 2, 3, 4, 5, 6. Then our last indeterminate form is so: infinity to the power of 0. So these are the 7 indeterminate forms that you will come across when evaluating some limits. So fundamentally speaking, these indeterminate forms are expressions that we cannot determine using a finite number or even infinity. There is no so objectively speaking, for these indeterminate forms, there is no objective value. There is no universally agreed value that they will lead to for these 7 indeterminate forms. So we can't say 0 to the power of 0 gives us 1. We can't say infinity minus infinity gives us 0. We can't say infinity to the power of 0 gives us 1. So before we try to apply L'Hopital's rule for this limit, we'll have to convert it into a rational form first. And to do that, what we will do is that we will convert secant x into a reciprocal form, into a rational form. And we know that secant x is 1 over cosine of x. So what we will get is ultimately a rational form function, which is x plus pi over 2 over cosine of x. We did a direct substitution earlier on, and we found out that this leads to 0, this leads to 0, so we can tell that this is an indeterminate form. And because it's an indeterminate form and it is a rational function, we can apply L'Hopital's rule. So what L'Hopital's rule says is that for the limit of a rational function, and if the numerator and the denominator leads us to an indeterminate form overall, what we can do instead is that we can take the limit of the derivative of the top function and the bottom function. So we'll take the derivative of x plus pi over 2 with respect to x, which gives us 1. Derivative of x gives us 1. Derivative of pi over 2, because it's a constant, it gives us 0. And then we take the derivative of cosine of x, which gives us negative sine x. And then we try to perform a direct substitution again. So we get 1 over negative sine negative pi over 2. So what we get is this. To find sine of negative pi over 2, recall your trigonometric graph. This right here is negative pi over 2, and this is negative pi. Negative 1 and 1, since sine x oscillates between 1 and negative 1. So sine of negative pi over 2 gives us negative 1. And don't forget the negative sign over here. So eventually, what this will lead us to is 1 over 1, which gives us 1. And therefore, the limit of x or negative pi over 2, the limit of the original function that we had at the start, is 1. And this is how you apply L'Hopital's rule to evaluate such limits.